In this video I will show you how to create your own MQTT server and then set up a Raspberry Pi Zero with Node-RED and a small VUE Web Client to communicate with that server. So first we will start by creating the server at DigitalOcean using Ubuntu 18.10. Install Docker and then install eclipse-mosquitto through DockerCompose. After that we will set up the Raspberry Pi Zero running Raspbian desktop operating system, and Node-RED comes already with that. And then a small VUE Web Client to communicate to our server through WebSockets, and the Raspberry Pi will use the standard port 1883 to subscribe from our server. So the first thing we will do is to go to digitalocean.com, log in or create account if you don't have one. You could use Linode or Amazon or whatever cloud provider you already use. Or you could even, if you have a server laying around with public IP, you could install Ubuntu on that one. So we will go to digitalocean.com, create droplet. Then we will select Ubuntu 18.10 64-bit. We will select the cheapest plan, which is more than enough for us. Have the server in Frankfurt and give it the name MQTT server. Create, and it only takes a few seconds to create. Then we have our server and we can copy the IP address. Then DigitalOcean sends us email with password to our new server. So we can just SSH into the root user to the IP address of our new server. And then we have to copy the password and paste it in here. Then we are inside the server. It asks us to change the password, so I paste it in again and put in my new password, and we are in. So our next task is to install Docker and then DockerCompose. And the reason we are running in Docker is that then we don't have to pollute our server with some changes that we want to do. If we want to try some different versions of the server or all things, so I definitely recommend Docker in all such cases. So it's a few steps to install. It's a good documentation on docs.dockercom how to install Docker CE. So basically it's just to follow these steps, copy paste commands that are listed in the Docker documentation. We need to install a few packages and apps like curl and software properties common. So we will paste it in here and answer yes to all the questions. We need the official GPG key, the GNU key, so we can the server can trust what comes from Docker. So we will copy paste that and install the key. And here is a procedure how to check that your key is correctly installed, so we can see that the last 8 bytes of our fingerprint matches. So it sure does. So that it is just to install the stable version of Docker CE into our repository. So when that is done, we can just install. Oh yeah, it's better to run update before, so it has the registry up to date, and then we can install Docker CE Commercial Edition. and then we can test our installation by running hello world and see if everything is looking good. Paste it in here, and it pulls the layer with a small layer with hello world, and here you see that your installation appears to be working correctly. That's good. And if you're running on Windows, you can do all the same commands. You just have to install GetSemcom. That gives you all the commands that is necessary, like SSH, etc. So you could just do root like we did on the Mac, and go through the same steps. And now I have changed the password, but you can do all the same stuff here from the Windows machine. The next thing is to install DockerCompose. It is rather easy. Follow the steps from docs.dockercom. Copy this line which fetches DockerCompose into our new machine. So paste it in here and it fetches DockerCompose. Then we just need to give DockerCompose the execution permission. So we're able to execute it, and then we're ready to go. We will create a new directory here and call Docker, and in there we will create a directory called MQTT, and then we just need 3 text files to get going. So first we need our config file for MQTT server, and let's call it mosquitto.conf. Then we need the password file for our users and password, and we need the DockerCompose YAML file. When we have these 3 files, we are ready to set up MQTT. We will start with the config file. We'll use nano editor here to edit our file, and I will go over it. Allow anonymous means that we don't allow anonymous access to our MQTT server. Password file is located in our Docker machine and at this path, mosquitto config password file. And we will listen to port 1883, which is a standard port for MQTT. So we don't have to specify the protocol here. But we also want to set up a listener on port 9001, and there we will be using the WebSockets protocol. So we will save this file. Then the password file, we will also use nano to edit our password file. Here we put in users and passwords. So we can have as many users as we wish. I will start with these 2 users, and what will happen here is that Mosquitto will then hash these passwords for us later, so it will not lie in the server in plain text format. Save that. And then the most important file, which is DockerCompose file. I will paste in the version that I've tried out and explain what's happening here. So we're using DockerCompose version 3.1. There are different versions of DockerCompose, so we have to be compatible with the version that we are using. Our first service here is Mosquitto. It uses the image eclipse-mosquitto, which is fetches from Docker Hub. The host name of our machine inside the Docker will be Mosquitto, and the container name in Docker will also be Mosquitto. Restart always means that this service will start when we restart the machine. We will expose these two ports that I explained, and from the outside it will be the same ports mapped to the inside of the Docker. So, and then what is important here is we will map into our Docker container to these two files, the mosquitto.com file, which is lying in our current directory, and it will map to the config location, and the password file from our folder will also map to the password file path that we also defined in the config file. So we will just try this out. We're ready to go. We have these three files, and we will just say DockerCompose up. It will read the config file. It sees it needs to pull down the eclipse-mosquitto. And here we see that it starts Mosquitto, and then it loads the config file. But then it says that our password hash is not, our passwords are not hashed, so it will remove the entries for these two users. So that we can solve by going here. So if we do docker ps with all here, we can see all our containers that we have created, and we see the hello world, which was the first one, and then we see mosquitto here with the name mosquitto. So what we can do, we can start it up again by doing docker compose up and detach. Then we don't have to let it take up our terminal. Then we can do docker execute interactive terminal into mosquitto. What is this? And we will run the shell command there. So now we are in our container, and as you remember, we put the config files here in mosquitto config here. So here we have our config files. We can see that they are owned by the root, but to be able to read the password file, we have to change the mode of this, the owner of these files to Mosquitto. So we will do that by saying change owner to Mosquitto. That is the user which is running the process inside our Docker machine. So we will just change these two files with the owner, and then we see that it is now owned by Mosquitto. You can't see the O here, but that's okay. Now if we cat our password file, we'll see that it's the original file that we had, but then we have one command inside our Docker which is called Mosquitto password. And if I just run it like this, it tells you that you can -u updates a plain text password file to be hashed passwords. So we'll just run that with -u and our password file. And if we cat out our password file now, we see that now the passwords are hashed and we are good to go. We can just exit this session here. So now we have our image here still with the old setup, so we will remove it, and when we run, yeah, we have to stop it first. So then we say docker compose down, so it will take down our containers. It already removed it. So if we run docker ps all, we see that it is gone. So now we can say docker compose up, and our server is up and running, and we don't get any complaints about our password file. We have our port 1883 ready and port 9001. And to test this, we can just go to our Windows machine here, and or maybe better if we just start this guy up like in detach mode. So now it is up and running, and if we go out of our SSH session, and we will get the IP address of our server again. We can just try telnet, which checks if the port on a specific IP address is open or not. So 1883, is that port open on server? And yes, it's connected, so we can start to communicate with it from here. And we will check 9001, and it is open as well. So now our server is ready. So now to the Raspberry Pi. Here we have Raspberry Pi 0. We have HDMI converter and USB converter, and power cable, and then we have the SD card and converter to USB. So to prepare the Raspberry Pi, we need to go to the Raspberry Pi download page and to the new out of the box download the zip file for noobs. After that is ready, we can do disk util list, so we'll see all the disk we have. And we see the 8 GB disk is here, number 2. So we just have to format that disk like this with sudo disk util erase disk with FAT32 format. The name is Raspberry and it's MBR format. Disk 2 is the path. So we will type in our password, and it will format the disk for us. So it's finished formatting the disk. We can just copy the content of our zip file to our newly formatted disk like this. And after we have copied all the files necessary, we will remove it from the USB converter, plug it into our Raspberry Pi, and connect the HDMI plug and USB plug of the Raspberry Pi 0 to our screen and keyboard and mouse, and set up the Raspberry Pi. So when the Raspberry Pi starts up, it comes up with a dialog to select the operating system that we want to use. We will select the Raspbian full, check that checkbox, and then hit the install button. So that starts the installation. It takes a while, and when it's finished it shows you this dialog. You just click on OK, and the Raspberry Pi reboots, and we can start to set up our newly installed Raspberry Pi 0. So we will begin by selecting our country and keyboard, then enter a new password, our Wi-Fi network for the Raspberry Pi, which it will remember, and then we update the newest software. So that takes a while also to run the update, go to the net and get all the newest updates for our operating system and applications. And when that is finished, the system is up to date, and we reboot. Or before we reboot, we have to configure a few things. We will give the Raspberry Pi a new name, so we will just call it Pi 0, so we can use that on our local network instead of IP address. So we will call it Pi 0. Then it's good to set the resolution to something that is usable for the VNC usage that I will show you a little bit later. So we will select 1280 by 720. Then it is good to select SSH interface and VNC, which we will use to connect to the Raspberry Pi. So we will hit OK, and now the Raspberry Pi after rebooting is ready. So the next task is to connect to our Raspberry Pi through VNC. So just download the VNC viewer from Real VNC. It's working good. And go here into the VNC viewer, make a new connection, pi0.local. Since it's on our local network, just call it pi0. All the defaults here. And then when we double click on it, it asks us to confirm the connection, and we will use the username and password that we gave up in the setup phase. And then we have our pi0 ready here. I increased the resolution a little bit so we can see a little bit more here. To start Node-RED, we just go to development and the Node-RED. Then it will start it up on the Raspberry Pi. We can set it up so it starts automatically on each reboot. That's just this command in another console. And Node-RED starts up, and then we are ready to access Node-RED from our PC just through pi0.local and port 1880. So now we are ready to start developing our flows. So I'll go to pi0.local 1880 and I'll get my Node-RED up on the pi0. So what we want to start with is to send something to our new MQTT server. So I'll just drag in an output node. You see input and output. Double click on it, and then we can add our server here. So I'll just have to go here, copy our address. We will call it MQTT server. Paste in the address. Default is 1883. Security. We will use our user 1 and password 1. Not the most secure user you could have, and I'm sure you figured that out already. We add it, and what we can see now is that the MQTT, when we click this button here, we will deploy our flow. And now it says, okay, successfully deployed, and it's connected to our server. And how do we know that it's working? Well, we can go just into our SSH into our server. And then we can look at Docker PS all, and we see that our instance is running here. It's been up 4 hours now. So I can say Docker logs mosquitto. So here we see we got a new client connected from this IP address. And what we can do here, we can say /f, and then we will get the updates when something happens. So it's fine to have it here on the other side. So we can just make this a little bit smaller. So we can inject something now. We can send a string to our server with the topic demo/light, and we will send light on to our server. See, done. And then we will drag a connection between these two components, the input and our output, and then we will just deploy our changes. And you see it reconnects here to our server. And now let's receive something from our server. So we will get the input node here, MQTT. We select the same server and demo light, which was our topic. And this is like a namespace, so you can define whatever you want, house, floor, room, or whatever. We will take a debug node here, connect to this. If I deploy this now, we get a new connection at our server, and I will send the light on, and we get the debug output you see from our server. So now it is working through port 1883, and only the WebSocket remains. What is good about this setup is that we can locate our Raspberry Pi Zero wherever we want, and we can put it into if in the garage we wanted to control our garage, we'll just put it there, and then we can start developing on the Raspberry Pi Zero just through the browser. So it makes things much easier. And then when the Raspberry Pi Zero starts up, it runs our flow and keeps it running. So I really like this setup of developing with these small devices. So to show this in action, I will just turn on and off an LED that I have. So we will search for GPIO, get the GPIO from the Raspberry Pi here. Connected to pin 40, have the initial state of 0. Now when we get light on message from our server, we want to change that into 1 and 0 that GPIO will understand. So I will make a small function here that will just call to 0 or 1. And we'll say if a message payload equals light on, then change the payload to the string 1, which GPIO will change to integer. Otherwise, change it to 0, like this. So we can wire this up like that, and deploy it like this. So we can just test it out. We see our servers here with our connection. We will send it the light on, and the pin goes to 1. So how do we turn the light off? Well, basically we will just send something else to our server. We can send let's say lights off. That sounds light off like this, and topic will be demo/light. So now we have light off here that we can connect to our MQTT server. Now we see that we go to initial state of 0, we turn the light on, it goes to 1, and we turn the light off, it goes off. So let's try this in action. So here I have a small LED that runs on 12 volts or up to 12 volts. And you can see that I have a boost up there from 3.3 to 12 volts. So just to have it something other than the standard LED that we use in these kind of demos, I will plug in the ground plug and then 3.3 volts to the GPIO pin number 40. So to demo it live, I just bring in my phone that's connected to the Node-RED on my Pi, open up the flow on port 1880, hit the on button, and the light is on, and the off. So you see that it's in action now, physical world. So the last thing we want to do in this presentation is to create a small web page that will control our let. So we will use Vue for that. So we'll go to vueify.com. That's a library that uses Vue and comes with all the material design components. So it tells you how to add Vue client to your PC and how to create your app. So I have already installed it, so it's version 3.4.1. So I can say Vue create MQTT web, and we could basically just use the default settings here because we don't need any router or Redux, which is called Vuex in Vue. So we just need some need two buttons to turn the LED on and off. So we'll wait for this to finish. So now we have created the web page. We will go into it. And we will add Vueify with Yarn, not with Vue, just to make it a little bit easier. If you use Vue, it will change many files, but we don't need that right now. So I'll set Yarn add Vueify, and it will add Vueify to our web page. I will open it with Code Insider, which is an editor I like. And we'll go here inside. We can just move it to the right. So we have the public folder with the index file and favicon, and the source files are here. So if you open up a terminal window here, you can just say yarn serve or npm serve, npm run serve. So it'll open up our web page, localhost 8080. So we will look at it. And we just get the standard Vueify template. So Vueify states here that we need to use Vueify because it's a component inside of Vue. So we will copy these two lines here, paste it into our main file like this, and then we need also to include the CSS file from Vueify. And we need to include some icons in the index file. So I will just paste that in here before the link. So if I save all this here, we can go into our web page and we can check out if we have any errors here. Everything is looking good. So what we can do is we will go to components, hello world. We'll remove everything here from the hello div. We need one div because it's a React design, so we need one head object here. So and we want some only want two buttons below. If I save this, you can see that we only have the icon now here, and we want two buttons below here. So how to solve that? We will go to here we have all our UE components, so we'll go to the components and buttons, look for some nice buttons. I think we will just use these big buttons here, so I'll go just with the alarm icon here. So I'll copy this and paste it in here, shift it a little bit in and give it maybe the color green. Let's see if we get a button. Yeah, we get a nice button here, and we will do copy paste of the same here and have it red. I'll just change the icons a little bit to something I know looks like a bulb, but it's actually a GPS icon. So it's GPS fixed, GPS not fixed. So then we can have two buttons. Can have this one green. Now we can have this one red maybe. So here we have a green button to turn it on and red to turn it off. We'll add the click event here. Click equals light on, and click light off. So here we have the script section of Vue. So we can add under the props methods, and we will add the light on method, and we can say alert on and off, like this. And you see we need comma here in between. So if we click on light on, we get on, and off is on also, but it should be off. Well, it doesn't matter. So now we need to include the PAHO MQTT JavaScript library into our application. And to do this, the Eclipse has a good repo here on GitHub that you can read how to implement this. But basically, the easiest way is to click on this file here, select all and copy, and put it into our public folder. Call it MQTT PAHO.js. Paste it in like this. So now we have MQTT JavaScript functionality in our app. So we need to also include it in the in-text HTML file, so that we can do by just putting a script tag here. So we can set a source as the base URL that takes us to the public folder, and -MQTT here. So we will change that to MQTT PAHO and save, and we get no error, so that means that we should have gotten the JavaScript file inside here. So you can just check it out by making this a little bit bigger. Yeah, see it here. And then just to add few lines of code to our Hello World component to actually send or publish our message. So we just need, I'll just try it out. We need data in our app, so we will define a function data that returns an object, and we will set our message here that we will going to send to our server, and then we will, in our method, we will just do one publish method here. So let's look a little bit on this one. We can maybe make this smaller here. So here we see that we will store the message in our data message, which is like a variable in our app. We will create a PAHO client with our web page and port 9001, because now we are using the WebSockets, and we will call this the Vue client. So MQTT will see this as a Vue client coming in. We will use MQTT version 3, which is the version that we installed. We have username user2 and password 2, so we can see that we are coming from the Vue client. And if we get on success, it will call the onConnect method. And what will the onConnect method do when it is connected to our MQTT server? It will just publish the message. And we had the topic was demo light, and this message is the message in the data, so that we store here. So in light on and off, we can just say this light on, and in the off we will say light off. Right, save. Okay, we will refresh our app here. We can take it out here maybe and see our Node 0 app here. Don't need this guy anymore, so we can close this and see if it works. We will turn the light on and we get on here, and we turn it off and we get off here, and I will show you in the phone that it's working in real life. I go into my PC to the specified address, and we get the web page up, refresh it, and then click on the button to see that the LED is on and off. Could have a little bit darker in the room, but that's the situation. So thanks for watching, hope you learned something. Take care.